important characteristics of parent functions and graphs. Some of these you should be familiar with, some of them might look new to you. Intercepts is one you should be familiar with. Our x-intercepts are when the graph crosses the x-axis, which means our y-coordinate is 0. And our y-intercepts are where the graph crosses the y-axis and when our x-coordinate is 0. So let's look at this graph we're given here. Where are the x-intercepts located? So if I scan across my x-axis, I touch 1, 2, 3 points, and the locations of those are at -1, 0, 4, 0, and 8, 0. So those are my x-intercepts. Notice the y-coordinate is 0 for all 3 of those points. And then if I'm looking for my y-intercepts, if I scan along my y-axis, I only touch one place, and we're going to just kind of guesstimate that that's at around 0, 1.5, and my x-coordinate is 0 because it's on the y-axis. All right, so let's talk about something that might be kind of new to you. Maxima and minima. That is just the plural for maximum and minimum. So the plural for maximum is maxima, and the plural for minimum is minima. We call these points on the graph extrema. So if you're ever talking about extrema, that is the general term for a maxima or minima. And we have two kinds. We have absolute, which means for the entire domain, that is the absolute highest or lowest point on the graph. And then we have local or relative maxima and minima, which is the highest or lowest point on a graph in a given interval. So let's look on this graph here. I've got arrows meaning it's going off to infinity in both directions. It's going upward. So looking here, how many extrema does the graph have? How many minima and maxima do we have? Well, here we're going and we bounce, so there is one of our extrema. Here we bounce, so there's another extrema, and look, there's a third. So anywhere that your graph is kind of changing direction or bouncing, that's where you would have an extrema. So a maximum or a minimum, and we've got 3 of them on this graph. Where on the graph is there a local minimum? Meaning somewhere else on the graph there could be a lower value, but for that area, relative to other values, it is a minimum. So looking here, my 2 minimums, right, a valley, if you will, which one is smaller? The one on the left, which means the one on the right would be more of a local minimum, and that is at the point 6, oops, I'm writing in the wrong place, 6, -2. So the local minimum there would be -2. When you're talking about a maximum or a minimum, you are referring to the y value. Where on the graph is there a local maximum? Well, on this graph, if I'm going off to infinity forever, I can't see the rest of it. So this maximum is going to have to be local or relative because I don't know if there's other values on my graph that are larger. And that is at the point 1, 2, but that value for the maximum is 2. So here is y equals 2 and y equals -2 for that local minimum and local maximum. What is the absolute minimum of the graph? Well, here, at this point, we can assume that our graph is just going up forever and ever. It's never going to go lower than this point here at -4, -7. So the absolute minimum is y equals -7. My graph will never be smaller or lower than at y equals -7. Then what about the absolute maximum of the graph? Well, it's going on forever and ever and ever, so we can't be sure. We don't see enough of the graph to know if it stops somewhere, what the highest it achieves, or it could be going off to infinity. So we can't be sure what the absolute maximum is of this graph. Okay. Another new characteristic of our graph is increasing and decreasing. So if you imagine a person is walking along your graph from left to right, if they are walking uphill, then that means your graph is increasing. If they're walking downhill, your graph is decreasing. When the person is at the top or the bottom of a hill or a valley, that would be the location for our extrema, right? A minimum or a maximum. They are neither increasing or decreasing. They're kind of stagnant. So we use parentheses for our interval notation at these boundaries. So let's look here. How many extrema does this graph have? Well, I've got one hill here and one valley here. So I have 2 extrema. And those are going to be the boundary points for our increasing and decreasing intervals, hint, hint. So over what intervals is the graph increasing? Intervals should give you a hint that we're going to be writing these in terms of interval notation, and we're talking about the domain, our x values. Over what x values is our graph increasing? Well, we're increasing when our guy is walking uphill. So from 0 to 2, we're increasing. So 0 to 2, both with parentheses. 1, because this is a hill. Remember, the top of the hill, it's neither increasing or decreasing, so we use parentheses. And right here, I don't know what's going on behind this graph. This is just where it starts, so I can't say for sure if it's increasing or decreasing. So we use parentheses for both sides of that interval. Then our guy decreases for a little bit up, and then he starts increasing again, starting at 6 and going off to infinity. So again, 6 parentheses because at the valley, it's neither increasing or decreasing. And then infinity also gets a parentheses, and I put a union between those 2 intervals. Okay, where is the graph decreasing? Well, if it's not increasing, then it's decreasing. My guy is walking downhill from positive 2 to 6. So 2 to 6, and those both get parentheses because both of those boundary points are my hill and my valley where it's neither increasing or decreasing. All right, and then one last characteristic we're going to talk about is positive and negative. We call our graph positive when it is above the x-axis, and it's negative when it's below the x-axis. So everywhere up here in the yellow is positive, and everywhere below in the blue is negative. So again, this one's saying determine the domain for which the graph is negative. So we're still looking at our x values. And then when the graph is on the x-axis, it's at 0, which is neither positive or negative, so we're using parentheses at that boundary point. So let's look at where we're negative. Where are we in the blue? Well, that's from -4 to 0. So again, interval notation, -4 to 0, those both get parentheses because they're on the x-axis, which means it's at 0, and 0 is neither positive or negative. All right, now over what domain is the graph positive? Well, these arrows means it's going off to infinity. So from -infinity to -4, and then from 0 off to positive infinity, we have 2 intervals for which our graph is positive, and we put a union between them. So these are the key characteristics for our graph that we are now going to apply to our parent functions and describe the characteristics of our parent functions.